Welcome to the digital lecture series. Uh, as we discussed the basic sequential circuit diagram and the feedback path is that, and as we also discussed that the basic element of sequential circuit is called as a flip-flop, and flip-flop can maintain a binary state indefinitely as long as the power is delivered to the circuit until the directed by an input signal to switch the state. Remember or note down that thing, a flip-flop circuit can maintain a binary state indefinitely. Maintain a binary state indefinitely up to how much? Until the directed by input signal. Until the directed by control by input signal. Okay. And there is a two states. Normally set means one. We say that set is equal to the output is one logically, and reset. Reset means output is zero. Two stable states are there, as in binary only two values are possible. So the major difference among the various types of the flip-flops are in the number of inputs they possess and the manner in which the input affected to the binary state. Most common types is called as a basic flip-flop. In some book it is also referred as a latch. And normally the two NAND gate and two NOR gate, two type of the possible of the basic flip-flop circuit. So let's see with the first thing. With the help of NOR gate, we will design the basic flip-flop with the help of NOR gate. This is also called as a latch. Remember that thing. So in NOR gate, what happens if any one input is 1, then output is equal to 0. Remember that. This is the basic behavior of that things. So in basic flip-flop with the help of NOR gate, two input reset set. These are called as a external input. While this is the cross coupled, the output. So it is also called as a cross couple SR flip-flop or SR latch. So the two external input means the gate number 2 have another input Q, and the flip-flop gate number 1 have a input Q dash with reset. Okay. So remember that thing, the Q and Q days are complement to each other. So as a starting point, assume that the set input is 1 and reset input is 0. Okay. Set input is 1 and reset input is 0. So as per the definition, if any one input is 1, it is not whatever the value of Q, it might be 0 or 1, the output is always 0. Q dash is 0. Now this 0 is passed here. So 0, 0, the output is 1 in NOR gate. Okay, in NOR gate, 0, 0, the output is 1. 0, 1, 1, 0, or 1, 1, always the output is 0. So here the final, if we Q equal to 1, 1, 1, the output is 0, 0, 0, output is 1. So it is called as a set stable state. Okay, so this input name is set. Now, after the same state, set is 1 to 0. What happens in this condition? So if the set is changed to 0 here, but already Q is 1, so 1, 0, the result is 0. and this 0 0 0, the result is 1. Okay, so it remains same. This is a special situation occur after the previous condition set is 1 and reset is 0. Okay, after this condition it happened. So we can say that this is a stable state. Means whatever the previous output is remain same, there is no change at the output side. Now, if we take consider that a set is 0 and reset is 1. So once reset is changed from 0 to 1, what happens the first q days? 1 0, the result is 0. And this 0 is passed here. 0 0, the output is 1. This 1 is passed here. And 1 1, the remains 0. So final stable state is that if set is 0, reset is 1, the q will become 0 and q dash will become 1. So this is called as a reset. Now here there is one different beauty. After this condition, reset condition, again my input will become 0 0. Means the reset is changed to 0 0, 1 to 0. At that time 0 1, the output is 0. 0 0, the output is 1. So it is after the set is 0, reset is 1 previous condition, the result remains same. Okay, result. So again the stable condition. So 0 0 value at that time the output is depends on the previous condition of input or previous condition of output stable. This is called as the output is not only depend on the input side. When a 1 is applied to both set and reset, now only one thing is remaining. There is a value, all SR combination 2 raised to 4. Out of these two, 0 0 is already occur, 0 1 is occur, 1 0, only 1 1 is remaining. So if both input are 1 1, okay, both input are 1 1, 1 and q dash. So if any one input is 1, 1 plus q dash is equal to 1 and its complement is 0. So it is not depend, q and q dash both are 0 0. Okay, if any one input is 1, output is 0. So q and q dash, this is called as a indeterminate state. And it is not a valid state, non-unvalid. This is the biggest problem in SR flip-flop and latch. So when if 1 is applied to set and the reset input, both Q and Q dash output goes to 0. This condition violates the fact that the output Q and Q dash are to be complement of each other. This is a wrong logical information. In normal operation, this condition must be avoided by making sure that ones are not applied to the both inputs simultaneously. This is the main limitation of basic latch or SR basic SR flip flop NOR gate. Now, this is the SR flip flop with the NOR gate. Now let's see a flip flop have a two useful state q equal to 1 and q dash is equal to 0. As already mentioned in the first two line of the truth table, this is called as a state. When q is equal to 0, q dash is 1. It is in the clear state 0 or reset state. So the complement of each other q and q dash are referred to as a normal and complement outputs. The binary state of the flip flop is taken to the be valued of the normal output. Under the normal operation, both inputs remain at 0 unless the state of the flip flop has to be changed. And the application of a momentarily 1 to set a input cause the flip flop to go to the set state. The set input must go back 0 before 1 is applied to the reset input. Momentarily 1 is applied to the reset input and flip-flop finally goes into the clear state. When both inputs are initially 0 and 1 is applied to the set input, the flip-flop is set state, or 1 is applied to the reset input while the flip-flop is in clear state. Leaves the output unchanged. When a 1 is applied to the flip-flop in the clear state, leaves the output unchanged. Okay, so the state is undefined and usually avoided if both inputs are goes to 0. The state flip-flop is indeterminate, depend on the which input remains the 1 long after the transition to 0. Now the same gate is also possible with the help of NAND gate. But here the thing is that the first input gate is called as a SAT. SAT and reset both are changed. In previous case, this input is called as a reset and SAT. In NAND gate, remember that thing, NAND gate, the truth table is if any one input is 0, the ending is 0 and complement is 1. Both input are 1, the output is 0. This is the operation of NAND gate. Okay, according to it, we have to consider. The first condition is that set is 1 and reset is 0. And here it is Q and Q dash. If any one is 0, the result is 1. And this one is goes to here. Q dash 1 1, the result is 0. Both are 0 0, remains same. So finally we got Q equal to 0 and Q dash is equal to 1. Okay. Now after this condition, if both are input is 0 0, both inputs are 1 1. After this condition, both inputs are 1 1. So this reset will be changed to 1. Remember that thing, NOR and NAND gate. In NAND gate, both inputs are 1 1. After this condition, okay. So 0 1 1 1 1 0. So it remains same. This is after S is equal to 1 and R equal to 0. Okay. So now 1 1 is a stable condition. Now set change to 0 and reset is remains 1. So reset is 1 and set is changed to 0. So set 0 and reset 1. If any one is 0, the output will become 1. This one is applied to here. 1 1, the output is 0 and this 0 is goes to here. So 0 0, the output is 1. So that means Q equal to 1, Q dash is 0. Okay. So reset is 1, the output is 1 0. So normally this is called as a reset bar and set bar or negative logical here. Now after that again 1 1. So this 0 changed to 1. But due to this 0, the remains same 1 and 1 1 the 0. Okay. So again it will become same stable condition. Only one condition is remain, both are 0 0. If both are 0 0 and this is Q, so 0 and that Q is equal to 0 and the complement is 1. So this is also 1. It is not depend on Q dash. So both are 1 1. It is invalid state. This is called as a state and reset bar set is there. Okay. So the application of this momentarily 0 to be set input cause the output Q is goes to 1 and Q dash is goes to 0. And thus the putting the flip-flop into set state. After the set input returns to 1, momentarily 0 to the reset input cause the transition to clear the state. So when the both input goes to 0, the both output goes to 1. A common 1 is a condition avoiding in normal flip-flop operation. So in this way, the basic flip-flop or RS latch is working. I hope is it making sense. Have a good day.